Welcome to today's webinar, Zoom In on Your Customers with Location-Aware Marketing, hosted by KXEN. My name is Andrew Savitz, and I'm the VP of Worldwide Marketing for KXEN, and I'll be moderating today's event. In this webinar, we'll discuss how location-aware data is exploding and how you can use this data in combination with predictive analytics to zoom in on each and every customer interaction, no matter where it takes place. We'll begin the webinar with an overview of KXEN, and then Julien Sauvage will discuss what geolocation means for predictive analytics, including a demonstration of location-based marketing. Specifically, in Julien's demo, he'll show you how you can integrate location-based marketing into an iPhone app to make personalized recommendations to your customers. Although I want to note that these same types of geolocalized recommendations could certainly be made in email, social media, websites, any customer-facing channel. We'll finish today's webinar with a live question and answer session, so please feel free to submit any questions during the presentation via the webinar Q&A panel, and we'll field as many of those questions during the call as time permits and answer any remaining questions after the call. To eliminate background noise, all phone lines will be muted for the duration of the event, and all participants will be in a listen-only mode. This presentation is also being recorded for replay purposes, which we'll make available to you after the call. Other than that, enjoy the presentation. Let's get started. So just a brief introduction to KXEN. We are a predictive analytics and data mining leader with over 500 customers around the world. You see lots of very large brands here worldwide, companies like Cox and US Cellular, Vodafone, Bell in Canada. We have companies like Wells Fargo and Bank of America, Discover, ING, Macy's, Sears, Rhapsody, Shutterfly, very large brands around the world that have selected KXEN, oftentimes in a B2C context, so in a business-to-consumer context, where they're engaging with their customers to use predictive analytics to predict things like, will you open an email if I send it to you? Or will you accept this deal or promotion if we extend it to you? KXEN has established our reputation and gained the level of traction that we have in the predictive analytics market because it's been our mission and our charter, and we have been the pioneer of making predictive analytics and data mining traditionally something that's a very complex science. We've made it available in an easy-to-use fashion across the business, where you don't necessarily need someone with a statistics, a degree or an advanced degree in statistics or machine learning, but to allow organizations to put predictive analytics in a business context to answer questions that they have in marketing or in operations or in risk or in fraud. So many different use cases. But we've pioneered this concept of automating that process in a way that organizations can do it in a very easy-to-use manner, but very quickly and very productively within the business so that they can answer as many business questions as they need answered or to accommodate as many marketing campaigns or customer interactions that need to be accommodated so that they can best engage with their customers. KXEN has a very established reputation in the market. You can see some examples here, but Gartner has called us a disruptor in the predictive analytics market. Forrester has named us a leader in the customer analytics wave, and we're a strong performer in the big data predictive analytics wave. And likewise, industry analysts like Aberdeen Group, David White did a benchmark analysis where KXEN has been proven to be faster than other predictive analytics and data mining solutions. So we pride ourselves on the market validation that we have and the recognition that we have in being able to produce predictive analytics solutions that make sense to our customers' business, and likewise to be able to innovate with technologies like and capabilities like geolocation, which we're talking about today. So with that, I want to turn it over to Julien, and let's talk a little bit about geolocation.
Thanks, Andy. If you look at this chart, it all started back 30 years ago 1983 with that big, ugly, heavy, not even a smartphone, but cell phone. I think the weight of it was like 5 pounds. And that was really the beginning of mobile devices in our everyday life. Today, that market has exploded. In 2013, the number of such devices, so I'm including smartphones, tablets, laptops, internet-connected phones, exceeds the world's population, 10 billion in 2013. Pretty amazing. We all live in a mobile connected world where the mobile network is part of our day-to-day life. And the estimations and the predictions are that by 2020, the number of such mobile devices will triple in size up to 30 plus billion devices in an Internet of Everything, as more and more objects of our life get plugged into the network. For example, smart toothbrushes and intelligent cars with M2M technologies. Today, I think we can say that smartphones are not just phones, but they are also web, GPS, calendar, camera, video, music player, of course, phones, and apps. We all do live in a universe of apps. As Gartner says, the handset becomes the hub of the personal. I think it's true. There's also an increased integration with networked customer electronics via mobile apps. And that universe keeps expanding. You see here the total number of iOS apps. Again, pretty amazing figures. Earlier this year in January, it was estimated around 800,000 distinct iOS apps. And other estimations by ABI Research gives us a number of app downloads this year of 70 billion. So it means that 70 billion apps will be downloaded this year. That's over 10 apps downloaded per human being on Earth. It's an expanding universe. And if we talk about location-based app, well, you can find all types of recommendations on these mobile apps. You have location-based apps for everything. So let's assume we are here in the KXEN headquarters, which is actually the case. We are here at the moment in San Francisco, 300 California. If you're around, just come and say hi. And you can find many sorts of apps around us. So if you want a social network with your peers who live nearby, you would have things like Facebook Places. You would have Foursquare with over 15 million people using Foursquare today. You want to do the same type of thing for more like business network. You can do that as well with apps like Mingle or Intro, pretty cool apps. You want to get a cab, there is a location-based app for that. It's called Uber, or you have other ones as well. You want to meet new people. I'm new to the city. I don't know many people, so I want to use things like Sonar or Intro to meet new faces around me. I want to shop. There is a great app for that. It's called Shopkick. I want to share media, again, based on where I am and my location. You would have things like Instagram or Locast. I want to work out. I would use Runkeeper, again, because I'm geolocalized. That will keep track of everywhere I go, and that would give me kind of the distances, where I run, my average speed, etc. These types of things. You want to date? Of course you can date with people around you with location-based app. You want to go to concerts? That's one app that I love. It's called Soundkick. You can keep track of the artists you like and keep track of all their live performances that will perform around you.
We try to see if Julian is actually working or if he's on his iPhone all day.
Yeah, I'm actually working, but yeah, that will be discussed after the webinar, I guess. That last example, you can use Gogobot and travel. Again, it's going to be a location-based app. So you really have a location-based app for everything. Even if you're thirsty, you got a great app. I used it the other day. Another example of the fact that I might not be working as much as I should. It's called Find My Tap, where I can instantly find craft beers spots around me. Pretty amazing.
This is since Julian moved from France to the Bay Area. He's got a new love for craft beers.
That's correct. The combination of all these phenomena, connected devices, the explosion of apps, and in particular location-based apps, makes us all as individuals more geolocalized than ever. And that, of course, has a direct impact on the data that is produced. You can now find geodata everywhere. It is, again, estimated that by next year, mobile web will outgrow the web, say the normal web, in terms of volumes of data. You have so many geodata sources today, of course, mobile devices with smartphones, tablets, we mentioned that, but of course, also you would have machine sensors, you would have any business having a mobile app would have data from that app, for example, with individual check-ins, wireless networks, even social media. Every tweet is what they call geotagged. So social media is often geolocalized as well. Emails, IP addresses contains geolocation data, although sometimes it might require an IP database to make it match with the actual longitude and latitude, but still the information, the geo information is there in the IP addresses. And last but not least, I would say everything like store information or your static addresses, the address of your work, of your home, all these things are by nature geodata. Data collection, just to make it clear for everyone, in the apps, data collection can be either passive or implicit. So passive means that the app works in the background and grabs your location. Implicit means the app reveals your location when you check in or when you take a picture or when you bookmark a place, etc. So because of that, data being everywhere, you can imagine the insights you will gain by being able to analyze this data. So this is, again, a person's itinerary. Let's assume that we again start in California Street at 300. Maybe that person would make a little break, go to a cafe in Howard Street in San Francisco, do some Facebook on his or her iPhone, then get back to work, and then work until the moment of the lunch break. Then he or she would go to eat somewhere in Chinatown, and maybe he or she would use Yelp as a great app for the cool spots and places and restaurants around him. Then he would get back to work for the rest of the afternoon, and then at the end of the day, he would work out. He might use the Runkeeper app or any other type of app like this. After he worked out, maybe he's going to shop a bit on Market Street. After he shopped, he might still have a bit of time to, walk around and climb the Kearny Street, share some pics with his European friends, pics he would have taken of Chinatown. This is typical from San Francisco. And the day is not over yet. It's starting to be dark. It's like 8 p.m. So maybe that person want to meet new people. He would use one of these apps that I mentioned before. He might meet these guys. They would have a couple of drinks in one of these cool Embarcadero spots. And because they get along well with each other, they might even go to a concert nearby in one of these piers in Embarcadero. And after that, he would use the last app of his day, and he would create the last geodata of his day by getting in cab to get back home.
Is this an example, or is this what you did yesterday?
That's what I'm planning to do today after the webinar. Yeah. So imagine the corresponding data you have here. Actually, you have data everywhere and all the time. There's no data only when you sleep, as long as you disconnect your cell phone. The whole point is this is a path. So this is one specific behavior that you can obtain on one given customer of yours. But maybe if you zoom in on someone else, you might see that the red guy here takes another path, kind of more south of Market type of person, so he doesn't go that much to Chinatown. And maybe the third person in blue would kind of stay within Chinatown and Powell Street in San Francisco and all this. So these concepts of paths, again, are creating value, are creating behavioral insight, And if you are able to analyze them and to pinpoint the exact location of your customers, then you know where your customer is on the map, and you can start building decisions based on this, based on the sequence of places that you visited, provided you analyze them with the right solutions. Let's talk a bit about KXEN now. So KXEN's predictive analytics now support geolocation, and this creates a huge opportunity for a variety of spaces, of use cases, of industries. Although the example we will present will be more marketing oriented, but this is just one example. So the three core capabilities are: number one, we natively identify the location of a person or a transaction using latitude and longitude, and we translate that data into a new variable type called geographic tiles or regions, which are then analyzed with KXEN. This new information can be used to enhance the accuracy of the predictive models by providing a highly personalized recommendation for a nearby store or a restaurant, for example. The second core capability is co-location. KXEN detects transactions or events occurring in the same location during the same period of time. And the third one is that notion of paths that we briefly touched in the former slide, where we create a sequence of geolocalized positions from time-based transactions to extract patterns of events. All right, let's now see an example relevant to location-based marketing and mobile apps. So we prepared a product demo on that. We'll see how our native support for geolocation will allow businesses to more precisely target their customers with location-based marketing. Building predictive models with geo-based data, we are able to identify the right offer, analyzing an individual's location, characteristics, and buying behavior. In my demo, I've selected to use a retail banking scenario where I'm a depositor and credit card holder at Bank of America. I'm also a user of their mobile app on my iPhone. I want to insist on the fact that this is a fictitious demo scenario and should be taken as complementary about the existing app and the deal's functionality. So what happens is this: using Bank of America's mobile app, I can do lots of things. I can check my account balances, I can pay my bills if I don't forget, etc. What's interesting is that by default, like many iPhone apps, notifications and location-based services are turned on. As you can see here in the center of your screen, you have banners that are turned on, and the right side of your screen, you see the location services that are turned on. So the notifications means that Bank of America is allowed to deliver messages to me with things like alerts or banners, something similar to a text message that I might receive. Location services, as described on the screen, on the setup screen, uses GPS along with crowdsourced Wi-Fi hotspot and cell tower location to determine your proximate location. Wow, that sounds familiar. It's purely location-based data, right? And in combination with the alerts and the mobile apps, hopefully you'll walk away with a glimpse at the art of what's possible using location-based marketing. I should note, while I'm showing you Bank of America mobile app, if you use any other banking app, I expect, if you're not already aware, you'll probably surprise yourself to see that these two settings are on your own phone. One really cool feature of that app, Bank of America app, is something called Bank America Deals, where Bank of America features deals and promotions with their merchant partners. Things like 10% off, 15% cash back. I think as a consumer, having discounts on food or retail purchases, even if it's PetSmart, which happens to be a kind of a pet shop or something, I think it's pretty cool. Movie rentals and all this, it's easy to understand, and if it's relevant, I would generally welcome that. What we want to do now in the demo is take this feature one step further. We want to take that to the next level, and we want to show you how we can personalize these deals even more by building predictive models which analyze not just shopping patterns, account balances, but also my current location. All right, so again, that's kind of a fictitious scenario, but not so fictitious. Let's assume that I've just visited Starbucks at Union Square in San Francisco. I bought my favorite peppermint mocha frozen frappuccino drink, which is something that I do like.
I was going to say, once again, not a very fictitious scenario in Julien's life.
Yeah, exactly. I come from France, so in France we pretty much have espresso, which is really good, but we don't have like crazy combinations of things like this with cinnamon and frappuccino, whatever. So I like this. This is new to me, and I've just bought that frappuccino using my Bank of America credit card, and using the merchant ID of the credit card transaction, Bank of America is able to pinpoint my exact geolocation, instantly knowing where I am in terms of latitude and longitude. Alternatively, as I mentioned before, Bank of America could use location services, which I had enabled for my mobile app, to identify my location. But in this example, we'll use the credit card transaction, since this is near real time as well and gives me a specific event from which I can pivot to my marketing deals. Right, so as you saw, we went with Google Earth in this case, which is just one example of the GIS, the Geographic Information System. We just started with the latitude and the longitude, and we zoomed in further and further, always getting at the street level. And yes, indeed, that longitude and latitude are corresponding to Starbucks coffee next to Union Square. So from that, the Bank of America is able to send me a 20% off deal notification on my iPhone to one of their merchant partners, Macy's, which is just around the corner. Well, pretty cool. As a matter of fact, I do need new Chuck Taylor's sneakers, and I do in fact shop at Macy's. So it's relevant. That's the point. How is that possible? Analyzing the location information just identified from my credit card transaction and any other characteristic or behavioral information, Bank of America has compiled from my account profile, account and credit card activity, past purchases, etc. Bank of America is able to use KXEN to build predictive models which hone in on what deal I would be most likely to accept after buying my coffee. And this is where I'm going to show you the results and how the Macy's offer could actually be selected. It's not coincidental that I was selected for the deal. In fact, there's a lot of intelligence behind it, and that's what I'm going to show you in the next part of the demo. Specifically, two critical steps. Number one, people that go to the same Starbucks in Union Square, San Francisco, often make their way to Macy's, as well as a few select merchants. These, again, are called the paths. Number two, analyzing Bank of America's 360 view of me, including my shopping history, demonstrates a high propensity that I will accept this offer. This is called predictive model, right? Or response modeling, or classification modeling, etc. So how is that possible? I'm going to switch to the original data that we used to obtain that. This is just an Excel spreadsheet, so you see a bunch of columns in here. You don't have so many columns. You have something like 7 columns, and of course you have lots of records. So that's the exact type of data that would be used in this example to be able to derive the paths. So how is that possible? We have a transaction ID here, one transaction ID per record. You would have customer ID as well, so the customer ID would tell me which customer made that transaction. You would have the amount of the transaction, the corresponding date, the merchant ID, where the transaction happened, and of course the latitude and the longitude of that merchant. And if I sort this, sorry, whoop, I think I made a mistake. If I sort this by merchant ID, just to show you the way it works, what you can see here is that in green, you have one same customer, Mr. 554 something, and in yellow, you have another customer, Mr. 464 something. And these two individuals actually happened to have visited the same merchants. In particular, this merchant, 22577, and also that merchant, 18977. So in other terms, these two merchants were visited by the same people around the same time. So that's exactly what we call a path, right? There's a path, a natural path or a natural association between these two merchants because they are visited by the same people more or less around the same time. And if we now go and see what KXEN produces, that's exactly it. That's going to be one output of your geolocation type of analysis. You would see a bunch of paths like this. If you double-click on one of them, you will be able to visualize the path in Google Earth. So that path, I've just taken it randomly. That path seems to associate two places. That one seems to be like the Moscone Center or Howard Street in San Francisco, and the other one is more south of Market. So people who tend to shop using their Bank of America credit card in this place then go to that place. It's interesting, right? It's just one path. So what I can do from now is visualize all the paths that are associated to San Francisco. Of course, it's going to be something pretty dense in terms of visualization. So these are all the paths taking the Bank of America customers from one place to another in San Francisco. It's pretty cool. So what we can do from there is, if you remember, we know in the scenario that Julian just swiped his credit card at Starbucks coffee, so I might as well just filter out all the paths and keep the three most frequent ones that are originating from Starbucks coffee. These are the three ones I can see here in my Google Earth departing from Starbucks coffees. You got a yellow path in here, you got a green one in here, and you've got a red one in there. And if we take one of them, let's zoom in a bit. Let's take the green path. It's going to start from Starbucks coffees. So lots of people have their coffee, and then they walk straight down the street. I think it's Stockton Street, and they stop here. And what's that? They stop here at Neiman Marcus, which happens to be a big retailer in San Francisco next to Union Square. So that's one shopping pattern. That's one shopping path. Going from Starbucks, people tend to go to Neiman Marcus. If we do the exact same type of analysis for the two other paths, the yellow one and the red one, we would see that the yellow one, let's zoom in a bit, the yellow one is actually going from Starbucks to Levi's, the jeans, and the last one, the red one, is going from Starbucks to Macy's in here. So that's it. We selected Starbucks coffees, and we now know that people who shop at Starbucks tend to go next to either Macy's or Levi's or Neiman Marcus. It's pretty cool. So these are the three most frequent paths taken by all the Bank of America credit card holders, not just me, originating from Starbucks. As you can see, geolocation data helps me narrow down the list of merchants, but still, we're not done yet, right? We need to determine which of the three is the right one to recommend to me, Julian. So in other terms, how can Bank of America personalize their marketing promotion? Basically not propose the same promotion to everyone, but only to people who are most likely to accept it. And this is where we're going to build a predictive model using, again, KXEN. So if we are looking at Bank of America's complete 360 view of your customer, including things like shopping patterns, like account balances, demographics, website click paths, etc., we are able to build a predictive model that shows what characteristics and behaviors determine who is most likely to accept a promotion at a retailers like Macy's or like Levi's or like Neiman Marcus.
Just to be clear, this is a data set that Julian put together to represent what a bank like Bank of America may collect about their customers from credit card transactions, from account balances, from all the types of information and behaviors behavioral information or click paths on websites, the things that an organization like a financial services company like Bank of America could be collecting to understand what their customers are doing, what their preferences are, what their behaviors look like.
Yeah, thanks, Andy. So one cool thing about about this data set is that you have one geo variable, right? We have only one. It's the shopping places. In other terms, it's the position or the combination of latitude and longitude of the place where people go to most frequently shop. So that's the last column in here. And again, we're about to build a predictive model, a response model based on past responses, past historical data. I want to know who's likely to go and shop at Macy's. So you need people who accepted or declined the Macy's offer, and the people who accepted it will have a 1 in here, and the others will have a 0. So you see, you don't have many ones. It's a pretty realistic type of scenario. We actually have 5.5% of 1s in here. You can remember that figure, 5.5%. So it means that in average, people accepted the Macy's offer with a 5.5% acceptance rate. Right. So let's use that data set, build the model. I'm about to build just one model, just the Macy's response model, not the Levi's nor the Neiman Marcus. These two other models are already built, and I'm gonna show that to you in a moment. So let's examine the results of the model. This is where you can see typically, things like the way KXEN stack ranks the variables in our 360 customer view to determine what's predictive. It seems like in our case, what makes people likely to accept the Macy's offer is the gross amount of the transactions. That's the number one variable. The second variable is the minimum balance. So people belonging to that category of minimum balance in, say, over a period of 1 month on their checking account, for example, people belonging to that category are really likely to go and shop at Macy's.
So when the bar is above the line, it's adding to their score, the percentage chance that they would accept that offer, and when it's below the line, for specific ranges, like you see on the bottom, account balance ranges, like 700 and, well, on a negative, $140 through $447, then they would be less likely, or subtracting from that score.
Yeah, exactly. So let's make it clear. I mean, the cut-off values, the thresholds, the categories, that was determined automatically by KXEN, right? So as an end user, you don't need to specify these values. It's all taken care of automatically by the solution. And the third variable that is a key driver to people accepting the Macy's offer, it's that geo variable we mentioned earlier, the shopping places, so where people tend to go and shop at. It's not going to be very easy to read, of course, because these are just like a bunch of latitudes and longitudes, but people shopping in these areas tend to go and shop at Macy's. And the cool thing, again, is that you can visualize that variable using, again, your good old Google Earth. So, and this is what we call the tiles. So this is the visual representation of your geo variable, the shopping places. The people who tend to shop frequently in the red zones, in the red areas, they are more likely to accept the Macy's offer. Whereas the people who tend to shop in the green areas, Civic Center, I'm not sure you've got tons of shopping places in Civic Center in San Francisco, but still, people who tend to shop in these green zones or areas are less likely to go and shop at Macy's. So the final part of the demo consists in applying all this. So for the demo, of course, I'm doing this in a batch mode, but KXEN can generate a scoring equation that can be executed in real time. And I'm just applying the three models, not just the Macy's, but also the Levi's, the Neiman Marcus models to one individual, Julian. And these are the probabilities or the likelihoods that I obtain. As you can see, the highest probability gives the best offer to propose to Julian, and that happens to be Macy's, as we said earlier. there's a 60% probability that I accept the Macy's offer. And if we switch back to the slides again, a 60% probability, remember I was telling you, remember the 5.5%? Well, what this 11x factor is explained like this. The 60% probability gives you an 11x higher lift than making an offer randomly that, as we said, was corresponding to a 5.5% acceptance rate. That scenario might be bank-oriented. I want to make sure that telco carriers, for example, the same type of scenario would apply to telco as well, because they would have the entire transactional data. Maybe it's not going to be credit card transactions, of course. It's going to be what they call detailed records, CDRs, with the corresponding geolocation data, but the same type of scenario and capabilities would apply to telco as well. Retailers, they have a lot of geodata as well. Maybe they don't own the transactional data at various stores. For example, of course, Macy's does not know that I went to Starbucks before I'm buying my sneaker shoes at Macy's. Having said that, now you can find solutions that give businesses access to a single consolidated consumer-based. It's based on communications, on industry communications, and I think it's a good path for retailers and businesses to use that data services and integrate it with KXEN on top to their m-commerce platforms, for example. So,
but in that retail example, things like point of sale and just looking at what people have purchased at checkout gives you great ideas about where they visited the store and which stores they're visiting. So lots of location-based information that's collected there.
Yeah. Well, that concludes the demo. There's one important note to consider before we wrap things up. In our example, we use geolocation data, that being latitude and longitude, determine things like the spatial tile in a grid where I'm located at the current time. However, in actual business use cases, companies might potentially build hundreds or even thousands of variables from geolocation data, like shopping patterns by location over successive periods of times. That's what you see here. You see a number of transactions in one specific geographic area, the last day, the last 2 days, the last 2 weeks, the last 3 months, etc. So you can derive time and geographic dependent attributes from geolocation data like this, and you typically end up having potentially hundreds, if not thousands, tens of thousands of such customer attributes. And it's a big data problem, right? You end up having really large, wide data sets with thousands of new dimensions, and you need to be able to build a robust predictive model regardless of how many variables exist. And that, as you may know, is a core strength of our product. It's a core strength of KXEN, and I guess it's an instrumental consideration to think about when you will use this data in your own company. As we have seen, KXEN's Infinite Insight now natively supports geolocation data in predictive models, enabling new insights to be derived from the various geodata sources. That insight, we focused on things like location-based marketing and mobile apps, but that insight can be used in a number of ways, for other industries, including fraud detection, including operations with, again, M2M type of data, and of course, including security, such as counterterrorism and border inspection patrol. To sum it up, using geolocation data in predictive modeling can allow you to zoom in on your customers, deliver even more relevant and targeted marketing to each individual, opening up huge opportunities to personalize customer conversations with location-based marketing, or do things like detect fraud, improve security, or optimize operational considerations. Geolocation is a capability which KXEN is uniquely positioned to address, and we hope this presentation and demonstration have given you some ideas on how you can take advantage of location-based information and predictive analytics in your own business.
Thanks, Julian. I just wanted to recap as well. I mean, in the demo, we saw Julian use path-based scenarios using geolocation to understand where people were most frequently going after Starbucks, and then using predictive models against each of those locations to understand the likelihood that Julian would actually go and shop at one of those individual stores or outlets if we offered him a deal or a promotion or alerted him to the fact that that this might be something that he should venture to do afterwards. The predictive analytics side, what KXEN has been doing for quite some time, and what you saw with this large list of customers that we showed in the beginning of the presentation, is really about predicting what people or what types of events are going to take place. And what Julian showed you when he personalized that interaction was kind of the who, the what, and the when. So of all of our customers, what behavior will they take? Will they shop at Macy's if we present them with an offer? And then the when, which is the time frame. Will he do that in the next hour, or will he do that in the next week, or will he do that in the next month? And analyzing all of the information, behavioral and characteristic type information about his customers in the 360-degree view of the customer, looking at other people that shopped at Macy's so that we can understand and predict if Julian will shop at Macy's. What does he have that resembles of all those thousands and thousands of attributes we know about our customers, and behaviorally about what we know about them, where they've clicked on our websites, where they've shopped, why do these people purchase at Macy's, and does Julian represent those characteristics so that it's probable that he'll go ahead and do that? So prior to jumping into questions and answers, I wanted to invite everyone to download a recent evaluation by Gartner on KXEN, where we were cited as a disruptor to the predictive analytics industry. And this report can be downloaded at www.kxen.com/Gartner. I also would encourage you, for those that are new to predictive analytics or are trying to think about and get their arms around these types of capabilities and how they can use them in their business, to come to our website and navigate around either from an industry perspective or from a product perspective, depending on the level of technical versus business use case that you're trying to understand, as well as under the Assets tab of our website, we have a variety of resources that are available, not just like this report here, but white papers that discuss the use of predictive analytics and explain what predictive analytics means for your business and how that you could go ahead and use that for your business. So we'll begin our Q&A with the questions we've collected from the questions and answers panel. And you can still post to this feed as we're answering questions, so I encourage you to do so. We'll respond to any unanswered questions shortly after the call. So don't worry about not getting a response if we don't have the time to do it on this call, although we have some available time to do that. So the first question is, what formats of geolocation data can KXEN analyze?
Yeah, it's a good question. Basically, we analyze longitude and latitude. That's pretty much it. Where the intelligence lies is the way we would treat that information, what we would do from that point, from that latitude and longitude. What we do is we would create a position variable or several position variables, like the one I showed in the demo, the shopping places. That was just one variable, but you can create as many as you want or as you need. And then these positions that would be within the same tile or the same region will be grouped together. And at this point, the positions will be replaced by the tiles. And the next step will be to cluster these tiles with respect to a business target. That way, we create a specific partition of your geographical area for each business question. And I think this is what we were kind of showing in here. This is really one partition of your space with one business question, which is, will the person go and shop at Macy's or not? But if the business question is different, then the partition and the little colors and the little squares in here would be different. So that's the format we use, and that's the processing we do out of these formats.
So that's actually a perfect transition, Julian, to the next question, which is that you've integrated potential paths from a particular location, in this example being Starbucks, with the predictive model. Now the question asks, you consider the top 3. Is that the rule of thumb? So best practice for, say, a mobile app, is it best to consider the top 3, or what would you recommend?
That's not a rule of thumb. That was more like the idea was to illustrate that demo scenario with something simple. I guess it depends on a couple of things. How many merchant retailers, how many merchant partners do you have if you're Bank of America or if you're another bank? If you have lots of them, maybe you shouldn't limit yourself to the top 3. Maybe you should have the top 10. Maybe you should have even more than that. Knowing that the beauty of KXEN is that it's so fast to build a model. Instead of if you need to build not 3 models, but you need to build 10 models, you can do that the exact same way. It would be the same analytical data. The only thing that would change would be the column. The binary column we showed during the demo where there was a 0, 1 for Macy's, so you would have a bunch of columns like this, but building the models wouldn't take that long. So I guess there's no unique answer to the question. It's more depending on what your business context and business questions are, and the top 3 was more for the demo than anything else.
Okay, so the next question, and hopefully we'll answer this correctly, and if we miss the context of the question, don't hesitate to let us know, we can follow up. But the question is, which countries can this be used for? In this example, we see Google Earth looking at the U.S., but I think the question is asking if geolocation data from any country or anywhere around the Earth could be used.
Yes. Answer is yes, of course. Sorry for being American-centric today, but the data set we used was based in San Francisco, but if you are able to, pinpoint where people swipe their credit card or where they're checking in Paris or somewhere else, in Asia, wherever on the globe, you can do the exact same thing. So again, that was just an example and not a limitation.
Okay, next question has to do with the definition of these regional tiles that KXEN creates, but if you could explain to what level of granularity you can do those tiles, as well as for the paths. We saw a sequence of 2 locations, Starbucks to a particular location, but how detailed and how extended can those paths be? Is it limited to only 2 locations?
Mm-hmm. Okay, so these are really 2 distinct questions. Question to the first one. The tiles, again, I think we can switch to Google Earth because it kind of gives a bit more context. So, and we might even, I'm doing that in real time. Let's see the tiles that we have. So that's the Macy's model. I can visualize the tiles in here. I will select them all, visualize it like that. So these are my tiles for the propensity to go and shop at Macy's. I can visualize this as well, and I'm going to explain this to you. Okay, so it all starts with really this. So you know you're in San Francisco, and you would just create like a grid. I hope you can see that on your screens. It's just like a basic grid of tiles that are all of the same size, and the size is totally settable by the end user. So the resolution you need is settable. If you need a very high level of granularity, then you would select a size for the tiles that would be really, really small. And if you're interested in something a bit faster and maybe not as accurate, then you would select a bigger tile size. But it starts like this. So you put that partition or that grid on your map, and then everything I've just mentioned about grouping the tiles with respect to one given business target, that would be done by KXEN, and you would obtain these grouped tiles. So you go from that grid to these tiles. So that's the answer, I guess, to the first question. And again, it's all done automatically. All you need to do is select and specify the tile size, and then KXEN does the heavy math for you. Answer to the second question, which was about the paths. No, again, there's no limitation. In my example, I used paths of what we call length 2, so going from one place to another, and you see them here. This is one KXEN interface. But we could have gone at level 3, for example. So these would be the paths that go from one place to another and then to another. And again, if we want to select that and visualize it in our Google Earth, I've just taken it random. Let's forget about the tiles. Forget about all the tiles. Right. So this is a path of length 3. So it seems like if I'm here around south of Market, then I'm likely to go to that place, and then I'm likely to go to that place. And you would have a bunch of such paths like this. If you go even up a path of length 4, then of course it depends on your data, right? So it seems like in my data with my time frame, I don't have a lot of paths of length 4. But there's no limitation within KXEN. It's the data that would dictate the maximum length of the paths to be extracted.
Thanks, Julian. So actually, another good question that follows on to the one that you just did, which is, given the use of paths, how can, in the capabilities in Geo-Loc, how can you use this for things like operations or urban planning, the examples that you mentioned before?
Well, examples of operations are, you got tons of them and very distinct ones. So there's a myriad of use cases. One of them would be you would use that concept of partition into tiles to help businesses allocate the right resource to the right geographical area, zone. That's one thing. What some of our customers are doing is also retailers, is you can optimize the next store location by performing what they call a store clustering using geolocation data. So you would typically know the geospatial and the geodemographical variables that make certain stores more successful in terms of profit or margin than others, and that would be helpful for you to determine the next best location if you want to open a new store. It's very operational, has nothing to do with CRM or with location-based marketing, and that's another example. Third example is predictive maintenance of any device, like a telecommunication antenna or mast or BTS, where typically the lifetime is better predicted when you use geolocation data. And all this, I want to make sure we're clear, this is just the beginning, right? So if we think about all the potential of the sensor data that is booming and that Internet of Things all being geolocalized, this is just the beginning of geolocation type of analysis for operations.
Terrific. We have a few more questions that we'll respond after the webinar to each of those individuals so that we make sure that we answer them. And I just want to, again, thank everyone for joining us today, for taking the time to join us today. And I also want to remind you of the report from Gartner that you can download, as well as a variety of assets from our website. So we encourage you to visit KXEN.com. And we'll be sending a follow-up email with a link to the replay of today's webinar and the Gartner report. So other than that, enjoy the rest of your day, and thanks for joining us.